So this is October November 2022, paper 2 variant 1. Let's start with it. Figure 1.1 shows a steel spring. Perfect. Figure 1.1 shows a steel spring. Describe an experimental procedure for obtaining the results needed to plot an extension load graph for this spring. Beta, we have to plot the Walaikum Assalam. We have to plot the extension load graph for this spring. How will you do that? First of all, you can do something to measure the initial length. You can attach a marker. You can attach a marker. Sure. You can say attach a marker. Walaikum Assalam. Assalamu alaikum to everyone. Walaikum Assalam to everyone who is joining. Beta, let's say you have a spring like this. Let's say you have a spring like this. Let's make a spring like this. You have a spring like this. You attach a marker to it. You attach a marker to it. Let's say this is L1 and measure this length. You attach a marker to it and measure a length of L1. Perfect. Now, after you place a load, what will happen? Beta, after you place a load, what will happen? This spring will expand. Let's say the spring expands like this once you attach the load. Perfect. So you also measure this complete length L2. You also measure this complete length L2. Perfect. Can you calculate the extension? Yes, extension is L2 minus L1. Can you calculate the force? You can calculate the force or measure the force of this block using a Newton meter, somewhat like that. Simple. So you can write it here. You can say attach, attach a marker to the spring and measure the initial length and measure the initial length. Perfect. Let's label this as L1. Perfect. Now, what will you do further? बेटा आगे क्या करोगे? You will say measure the force, measure the force of a block, measure the force of a block using a Newton meter, using a Newton meter and attach it to the spring and attach it to the spring. Simple. Now, last step, measure the, measure the final length, measure the final length of the spring, measure the final length of the spring. Perfect. Let's label this L2 and calculate extension using L2 minus L1. Perfect. And repeat this procedure, repeat the procedure, and repeat the procedure 2 to 3 times and plot a graph. And plot a graph. Simple as that, nothing complicated. This is an answer that will bring a distinction home. Let's further move ahead. Part B value. In an experiment to obtain the results for the extension load graph, a spring is at stretched beyond limit of proportionality. Okay. The spring is stretched beyond its limit of proportionality. On figure 1.2, we sketch the extension load graph for this spring. You have to sketch the extension versus load graph. What will you say? Let's say extension versus load graph will have something like this. After limit of proportionality, after limit of proportionality, it will start curving towards the extension axis. And which is the axis of extension? Y axis. बेटा हमेशा याद रखो आफ्टर लिमिट ऑफ प्रोपोर्शनैलिटी योर ग्राफ स्टार्ट्स टू curve towards what? Your graph starts to curve towards the extension axis. Here your extension axis is the y axis. On figure 1.2, mark and label with a p the limit of proportionality. Okay, so we have to label it with a p. Let's say this is your limit of proportionality. Simple. The limit of proportionality for this spring occurs at 8.5 newtons. Perfect. The extension of the spring is 0.014 meters with a load of 3.5 newtons. Perfect. बेटा जब आपका लोड 3.5 न्यूटन है तब आपकी एक्सटेंशन है 0.015 0.014 मीटर्स. Calculate the extension for a load of 5.5 newton. Perfect. So beta, if your load is 3.5, your extension is 0.014. What will be the extension if your load is 5.5 newton? Apply ratio method. What does x comes out to be? 5.5 into 0.014 divided by 3.5. What does your extension comes out to be? बेटा एक्सटेंशन क्या आ जाती है 0.022 meters is your extension. 0.022 meters is your extension. Nothing complicated here. अच्छा सर हमें फोर्स की जगह वेट लिख सकते हैं. लिख सकते हो लिख सकते हो लिख सकते हो. हाँ हाँ.
सर,
हाँ हाँ पूछो पूछो.
जो फर्स्ट क्वेश्चन था जिसमें एक्सपेरिमेंट करना था, तो उसमें मैंने काफी चीजें लिखी थी क्योंकि मैं श्योर नहीं था ना कि कितने लिखना है। तो मैंने उसमें
हाँ
ये भी लिखा कि
यही करना
पहले
होता है.
स्प्रिंग, मैंने लिखा हैंग द स्प्रिंग ऑन अ हुक,
हम्म.
यूज अ क्लैंप, होल्ड अ मीटर रूल वर्टिकली एंड मेजर स्प्रिंग्स लेंथ. This is
हम्म.
the length with no load. Then add loads of different weights by hanging them on the other side of the spring, which is the spring's bottom.
हम्म.
And then extension calculate करने के लिए जो अभी लोड के साथ निकला है माइनस द इनिशियल एंड देन प्लॉट अ ग्राफ.
सही है. ठीक है. गुड इनफ. गुड इनफ. चलो आगे बढ़ते हैं. लेट्स मूव ahead. A child's toy consists of a flexible track and a model car. Perfect. Figure 2.1 show the diagram of the toy. Okay, so this is the diagram of the toy. The child first holds the car stationary at point A. बेटा आपने first of all कार को stationary रखा हुआ है at point A. Perfect. ठीक है. So here at A your velocity is 0. That means at point A the kinetic energy is 0 joules. Perfect. And point A is at a distance of what? 0.45 meter above the horizontal section. The mass of the car is 0.12 kg. Perfect. The height is this. The mass of the car is 0.12 kg. Perfect. The child then releases the car, which travels towards point B. Both air resistance and friction between the car and the track are negligible. Perfect. The gravitational field strength is 10. Perfect. Calculate the change in gravitational potential energy of the car as it travels from A to B. You have to calculate the change in gravitational potential energy of the car. How will you calculate the change in gravitational potential energy of the car? mg into change in height. Beta, what is the mass? Mass क्या है 0.12. What is g? G is 10. What is height? 0.45. Can you calculate the change in gravitational potential energy? Yes. The change in gravitational potential energy comes out to be 0.54 joules. Simple. Let's further move ahead. Calculate the speed of the car as it reaches B. So, beta, as you reach B, as you go from A to B, what is happening? Gravitational potential energy at A gets converted into kinetic energy at B. You can write it here. Gravitational potential energy at A gets converted into what? Kinetic energy at B. What is the gravitational potential energy at A? 0.54. Perfect. What is the kinetic energy at B? 1 upon 2 into the mass into velocity का square. What is the mass बेटा? Mass क्या है 0.12. Perfect. Mass is 0.12 into velocity at b का square. Can you calculate the velocity at b? Beta, can you calculate the velocity at b? Yes, the velocity comes out to be 3 ms minus 1. The velocity comes out to be 3 ms minus 1. Perfect. After releasing it, the child expects the car to follow the track along the route A, B, C, D, E, F, G. In fact, the
सर एक
model
क्वेश्चन
car.
है।
हाँ हाँ, पूछो पूछो।
सर ये जो उनसे हमने ग्रेविटेशनल पोटेंशियल एनर्जी काइनेटिक की इक्वल रखा है, आज सिर्फ हम तभी कर सकते हैं जब बॉडी नीचे आ रही है, कि जब बॉडी ऊपर जा रही है तभी हम ये कर सकते हैं।
हर वक्त कर सकते हो, नीचे जा रही है ऊपर आ रही है। You can apply it anywhere. You have to just take care of this wording. कि आपके सवाल में एयर रेजिस्टेंस एंड फ्रिक्शन क्या हो, नेग्लेजिबल। अगर एयर रेजिस्टेंस एंड फ्रिक्शन आपके सवाल में निग्लेजिबल हैं बेटा, तो काइनेटिक एनर्जी और ग्रेविटेशनल पोटेंशियल एनर्जी एक दूसरे में पूरी पूरी इंटरचेंज हो जाएंगी। हाउ एवर, चलो अच्छा सवाल पूछा है, इसको थोड़ा सा डिस्कस कर लेते हैं। इफ यहाँ पे एयर रेजिस्टेंस और फ्रिक्शन अगर निग्लेजिबल नहीं होती, अगर फ्रिक्शन और एयर रेजिस्टेंस निग्लेजिबल नहीं होती, तो बेटा क्या होता? जो ग्रेविटेशन पोटेंशियल एनर्जी है, सम ऑफ इट वुड बी यूटिलाइज फॉर वर्क डन अगेंस्ट फ्रिक्शन, सम ऑफ इट वुड बी कन्वर्टेड इनटू काइनेटिक एनर्जी एट बी। ठीक है, तो ये एक मसला है। अगर एयर रेजिस्टेंस फ्रिक्शन निग्लेजिबल है, यू कैन ऑब्वियसली राइट दिस। चलो लेट्स सी दिस। After releasing it, the child expects the car to follow the track along A, B, C, D, E, F, G. In fact, the model car does not reach its F. अच्छा जी। बेटा, जो स्टूडेंट है वो एक्सपेक्ट कर रहा है कि कार ए से बी, बी से सी, सी से डी, फिर डी से ई, ई से एफ ट्रैवल करके जी से बाहर। ये एक हॉट व्हील्स का ट्रैक है, इफ़ यू हैव प्लेड दैट। ठीक है, तो स्टूडेंट ये एक्सपेक्ट कर रहा है कि ये होना चाहिए, बट द car does not reach F. Why? Why? Because there is not enough kinetic energy to travel beyond point D. बेटा ये पॉइंट डी देख रहे हो? पॉइंट डी के बियॉन्ड कार जा ही नहीं सकती, बिकॉज यू डोंट हैव इनफ काइनेटिक एनर्जी टू ट्रैवल बियॉन्ड पॉइंट डी। सिंपल। सो यू कैन राइट। एंड व्हाई इज दैट द केस? व्हाई इज दैट द केस? बिकॉज बेटा पॉइंट डी सेम हाइट पे है पॉइंट ए की तरह। Point D is at the same height as at point D, ठीक है। सो एट पॉइंट ए, बेटा पॉइंट ए पे आपकी पूरी की पूरी एनर्जी ग्रेविटेशन पोटेंशियल एनर्जी थी, देयर वाज नो काइनेटिक एनर्जी। इफ पॉइंट डी इज एट द सेम हाइट, देन ऑल ऑफ द एनर्जी एट पॉइंट डी विल बी ग्रेविटेशन पोटेंशियल एनर्जी, द काइनेटिक एनर्जी एट डी विल बी जीरो। काइनेटिक एनर्जी एट डी जीरो हो गई, तो बेटा वेलोसिटी एट डी विल बी जीरो। नाउ टेल मी हाउ अ कार विथ वेलोसिटी जीरो कैन गो अराउंड द ट्रैक? So you will write not enough kinetic energy, not enough kinetic energy to travel beyond point D. Simple. Immediately after being released at A, the car travels to B, to C, and then to D. Describe the motion of the car after it reaches D. बेटा आपने motion of the car बताना है after it reaches D. Yes. What will happen after it reaches D? Motion of the car. A से B गए, B से C, C से D. What will happen then? It will start returning backward from D to C, C to B, B to A. So you can write it here. You can write it here. The car starts moving backward. The car starts moving backwards from D to C to B to A. Simple as that. लेट्स फर्दर मूव अहेड बेटा। अच्छा, ये मैनोमीटर्स के सवाल हैं, दीज हैव बीन एक्सक्लूडेड फ्रॉम द सिलेबस, अब ये नहीं आते, ये सिलेबस का पार्ट नहीं है, सो आई एम स्किपिंग दिस। लेट्स डू दिस। X-rays are transverse waves that are part of a spectrum of waves. Perfect. State the name of the spectrum of waves that include X-rays. बेटा ऐसा कौन सा स्पेक्ट्रम है जो X-rays को इंक्लूड करता है? इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम। इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम। परफेक्ट। Describe what is meant by frequency. Okay, what is meant by frequency? The what is meant by frequency? Number of oscillations per unit time. You can write number of oscillations. ओहो 3 लिख दिए अरे यार what is happening today to my handwriting? Number of oscillations per unit time. Simple, nothing complicated here. State the name of the waves in this spectrum that have the greatest frequency. Beta, which waves have the greatest frequency? Gamma rays. Gamma rays. Simple. X-rays are used in hospital to produce an image of broken bones. Explain how this is done. You may draw a diagram if you wish. Now, please remember, whenever the examiner has provided you a space for the diagrams, don't leave it empty. Whenever the examiner has provided you a space to draw a diagram, don't leave it empty. He is giving you some kind of respect. Please take that with both hands. Now, what will happen? What will happen? Yes, क्या करोगे? What will happen? You will say, you have an X-ray emitter. You can say that you have an X-ray emitter like this. Let's say this is an X-ray emitter. Perfect. This emits X-rays. This emits X-rays. Perfect. You can also draw a human body. Let's say this is a human body. Human body. Perfect. And what is the final thing that you must draw? You must draw a CMOS detector. CMOS detector at the back of the human being. परफेक्ट एक एक्सरे बना दो बेटा एक्सरे इमिटर एक ह्यूमन बॉडी बना दो एक सीमॉस डिटेक्टर बना दो सिंपल एज दैट नथिंग कॉम्प्लिकेटेड नाउ व्हाट हैपेंस प्रोसेस होता क्या है x-rays are basically directed towards the body the x-rays pass through the flesh but they cannot pass through the bones an image is produced by the CMOS detector this is how x-rays work you can write it here. You can say X rays are directed towards the body. Simple. X rays pass through the flesh but are blocked by what? But are blocked by bones. But are blocked by bones. Simple. The image is produced by the CMOS detector. By the CMOS detector. Simple as that. Let's further move ahead. Explain why X rays are not used for prenatal scanning. Now, what is prenatal scanning? Prenatal scanning is the scanning of newborn babies. So, why is X rays not used for prenatal scanning? Yes, because X rays might cause cancer. X ray can cause harm to what? Harm to the small baby, to the infant that is still not born. Prenatal scanning beta कब होती है? Before even the baby is born. So it might cause cancer, it might cause cell mutation, it might affect the birth. So all these are possible. So you can say X-rays can cause cancer or harms to the infant. Simple. Let's further move ahead. Let's see this figure 5.1. is a diagram that shows the number of particles in a charged ion of beryllium. Perfect. This is the number of particles in a charged ion of beryllium. Perfect. Now let's move ahead. The charge of an electron is negative 1.6 into 10 raised to the power of minus 19 coulomb. Perfect. The charge on the ion is 3.2 into 10 raised to the power of minus 19 coulomb. Deduce from the charge on the ion the number of protons in the nucleus. बेटा हमने नंबर ऑफ प्रोटॉन्स रिड्यूस करने हैं इन द न्यूक्लियस. Currently, the charge on the ion is this. Perfect. If the charge on the ion is 3.2 into 10 raised to the power of negative 19, what does this means? This means बेटा 2 इलेक्ट्रॉन्स इनिशियली यहाँ पे थे जो अब एक्सपेल हो गए. This means 2 electrons have been expelled from the valence shell. If the charge on the ion is 3.2 into 10 is the power of minus 19 coulomb, this means what? Electrons have been expelled from the valence shell. This causes the charge to become what? 3.2 into 10 is the power of negative 19. So if beryllium was neutral, बेटा अगर beryllium का charge 3.2 into 10 is the power of minus 19 नहीं होता तो there would have been how many electrons? 1, 2, 3, 4. And in a neutral atom, the number of electrons is same as the number of protons. 4 will be your answer. ये बात समझ आई? Yes or no? Tell me in the chat ये बात समझ
हाँ
आई?
सर.
हाँ हाँ बोलो.
सर उसमें तो 2 इलेक्ट्रॉन्स पहले ही से प्रेजेंट है, तो फिर उनका चार्ज माइनस होगा तो 6 नहीं हो जाएंगे प्रोटॉन्स?
हम्म.
लाइक -1.6 मल्टीप्लाई बाय 10 पावर -19 मल्टीप्लाई बाय 2 पहले करेंगे और फिर माइनस
बेटा
करके निकाल.
प्रोटॉन्स भी तो प्रेजेंट है ना ऑलरेडी 4. वो तो 2 को वैसे ही
नहीं,
माइनस कर.
लेकिन जो ओवरऑल चार्ज होता है वो तो इलेक्ट्रॉन्स और प्रोटॉन्स का मिलाकर होगा ना आयन का.
हाँ ठीक है. तो प्रोटॉन्स 4 हैं, इलेक्ट्रॉन्स 2 हैं, चार्ज क्या हो जाएगा?
अच्छा हाँ. अच्छा ठीक है ठीक है.
किसी का और कोई सवाल? 1 सेकेंड.
सर हम
नहीं
लोग डायरेक्टली पीरियोडिक टेबल से देख सकते हैं?
बेटा क्या फिजिक्स में तो मुझे नहीं लगता पीरियोडिक टेबल देते हैं. नो.
सर अगर याद हो तो हम लोग
हाँ
बता दें.
याद हो तो कर सकते हो, लेकिन देखो अब इसमें भी एक गेम है ना. अगर वो एक काम कर दे, ये देखो वो आपके दिमाग के साथ ज़रूर खेलेगा वो इस दिन पे. कभी तो कभी खेलेगा ये कि ये वाला इलेक्ट्रॉन भी रिमूव कर दे. अब आपको अगर याद है कि बेरिलियम ग्रुप 2 में है, वो 2 प्लस ही आयन बनाता है. लेकिन अगर 3 इलेक्ट्रॉन्स मिसिंग होंगे तो फिर आप कैसे इनकाउंटर करोगे? तो इसका बेस्ट तरीका यही है कि हमेशा चार्ज को देख लिया करो कि पॉजिटिव चार्ज क्या है आयन पे. 3.2 इंटू 10 टू द पावर ऑफ माइनस 19 कूलम्स. और अगर इतना आपको चार्ज चाहिए, दैट मीन्स 2 इलेक्ट्रॉन्स को आप एक्सपेल आउट करा रहे हो. वाई? बिकॉज ईच इलेक्ट्रॉन पे चार्ज क्या है? 1.6 इंटू 10 टू द पावर ऑफ माइनस 19. अगर बेटा आपने 2 इलेक्ट्रॉन्स एक्सपेल आउट कराए तो इनिशियल नंबर ऑफ इलेक्ट्रॉन्स क्या थे? 1 2 3 4. If initial number of electrons were 4, the number of protons will also be 4. Perfect. Okay, so you also have to tell the nuclide notation of the charged atom. Perfect. So can you realize this has 4 protons? 1, 2, 3 and 4. How many nucleons do you have in total? 1, 2, 3, 4 protons. And how many neutrons do you have? 1, 2, 3, 4, 5. So there are 5 neutrons and 4 protons. How are you going to write the nuclide notation? Very, very easy. Beryllium 4, 9 will be your answer. Always remember, on the bottom side you have the proton number. On the top side you have the proton plus neutron number. Simple. The isotope in figure 5.1 is the only stable isotope of beryllium. Explain the term isotope. How do we define isotope? Now you can write this definition if you want to. Isotopes are molecules of the same element. Isotopes are molecules of the same element with the same number of protons but different number of nucleons. You can say isotopes isotopes are Molecules or atoms of the same element having same proton number, having same proton number but different nucleon number, but different nucleon number. Simple. Let's further move ahead. आगे बढ़ते हैं. Explain what prevents electron in an atom from escaping. बेटा electrons in an atom escape क्यों नहीं कर जाते? Why don't they escape? Why are electrons prevented from escaping? Because electrons and nucleus is oppositely charged. Nucleus क्या होता है बेटा? Positively charged. Electrons are negatively charged. This creates a force of attraction between the unlike charges. So you will write that there is a force of attraction. You will write that there is a force of attraction between what? Between negatively charged, between negatively charged, negatively charged electrons and what? And positively charged nucleus. And positively charged nucleus. Simple as that. Nothing complicated here. Let's further move ahead. आगे बढ़ते हैं. An electromagnet is used to separate objects that are magnetic from objects that are non-magnetic. Okay, an electromagnet is used to separate magnetic objects from non-magnetic objects. Perfect. Figure 6.1 shows the electromagnet suspended from the arm of a crane. Perfect. State the name of the metal which is used as the core of the electromagnet. Beta, which metal is used as the core of the electromagnet? Iron, or you can say soft iron. Chalo, part B try karo. Try out part B. Each and every one of you try out part B and tell me the answer in the chat. Part B, try out karo and tell me the answer in the chat. What do you have here? What do you have here? You have the voltage, you have the current. Can you calculate the power, beta? Yes. Power is equals to IV. Current is 39. Voltage is 220. What does your power comes out to be? 39 into 220. This comes out to be 8580 volts. Simple. Let's further move ahead. The DC supply is a set of batteries. Perfect. The DC supply that we are providing here is a set of batteries. The batteries power the magnet for 4.5 hours before they need to be replaced. Calculate the charge driven around the complete circuit in this time. Okay, we have to calculate the charge driven around the complete circuit in this time. What do we know? Voltage is equals to work done over charge. Perfect. Voltage is equals to work done over charge. ठीक है. We have to calculate the charge, right? We have to calculate the charge driven around the complete circuit. हम क्या कर सकते हैं यहाँ पे? There is a very very easy way to do this. What can we do here? We can say 39. यहाँ हम ये कर सकते हैं. You can say that charge is equals to current into time. What is the current here, beta? Current क्या है यहाँ पे? 39. 39 multiplied by the time of 4.5 hours. 4.5 into 60 into 60. What does your charge comes out to be? 39 into 4.5 into 3600. What does the charge comes out to be? Yes, the charge comes out to be what? चार्ज क्या आ गया बेटा? ये क्या हुआ? 1 second. अच्छा, it wasn't showing on the screen. 1 second. ओके, हम बेटा यही फॉर्मूला अप्लाई करेंगे अब द रिमाइंड गुड, वी विल अप्लाई दिस फॉर्मूला। अच्छा ये आ गया, there is some problem with one note but here we have it. The charge comes out to be what? 631,800. Obviously you can turn it into three significant figures or two significant figures. What is this यार, ये क्या हो रहा है? एक सेकेंड, वन सेकेंड, why is this disappearing? चलो यहाँ पे कर देता हूँ. Now the batteries power the magnet for 4.5 hours. You have to calculate what? You have to calculate the charge in the complete circuit. How will you calculate the charge? Charge is equals Q is equals to IT. The current is 39 multiplied by the time, that is 4.5 into 60 into 60. The answer comes out to be what? The answer comes out to be 631,800 coulombs, which can be written as what? This can be written as 6.3 into 10 raised to the power of what? 10 raised to the power of 5. Simple. On a very cold morning, okay, on a very cold morning, when the electromagnet is first switched on, the current is greater than 39 ampere before decreasing to the usual value. Explain why the current is greater than 39 ampere initially. बेटा initially current 39 ampere से greater क्यों है? Because on a cold, because if temperature decreases, the resistance decreases. This causes current to increase. This causes the current to increase. Simple तरीन आंसर, nothing complicated here. बताओ ज़रा इस सवाल में कोई मसला? Any ambiguities, any difficulties here भाई? कोई मसला? So we have to start with this question. Let's see. Let's read out. Figure 7.1 shows a child sitting on a sledge. Okay. Figure 7.1 shows a child sitting on a sledge. Perfect. क्या कह रहे हो? वालेकुम अस्सलाम. Very good. Figure 7.1 shows a child sitting on a sledge on a snow covered hill of a constant slope. Perfect. So this is a child sitting on a sledge. This is a snow covered hill. This is a wall. Perfect. At time t is equals to 0, the child and sledge began to move down the hill in a straight line. At time t is equals to 0, the child and sledge began to move down the hill in a straight line. Perfect. When the child sees a wall ahead, बेटा जैसे ही ये child wall ahead देखता है, he applies the brake. Perfect. The child and sledge continue to travel in a straight line until they come to a stop before hitting the wall. Perfect. Until they come to a stop before hitting the wall. Chalo. Figure 7.2 is the speed time graph for the journey. Perfect. Figure 7.2 is the speed time graph for the journey. Simple. The brake is applied at time t is equals to 26 seconds. The brake is applied at time t is equals to 26 seconds. You can see here at time t is equals to 26 seconds, you are applying a brake, your velocity is decreasing. Perfect. Figure 7.2 shows how the speed of the child and sledge varies over the whole journey. Okay, so we are shown how the speed of the child and sledge varies over the whole journey. Perfect. Explain why between time t is equals to 0 and time t is equals to 26 seconds, the speed varies in the way shown by the graph. Okay, why is the speed varying like this? Why is the speed varying like this? Whenever you have a velocity time graph of this shape, beta, what will you say? जब भी आपके पास velocity time graph होगा of this shape, what will you say? You will realize that this is a terminal velocity का graph. बेटा, you will realize that this is a terminal velocity का graph. हाँ, कह सकते हो decreasing acceleration. You can say that. Why is this a decreasing acceleration graph? Because if you realize the gradient of velocity time graph is acceleration, and as gradient is decreasing, acceleration is decreasing. Simple as that. परफेक्ट। तो हमारा ये ग्राफ क्या बना है? डिक्रीजिंग कर्व, सिंपल एज दैट, नथिंग कॉम्प्लिकेटेड। So you have to explain, you don't have to. Maybe you can write this as a key point that acceleration is decreasing, but you have to explain more. You have to add more details why between time t is equals to 0 and time t is equals to 26 seconds, the speed varies in the way shown. Can you realize as the speed of this child and sledge will increase, the resistive forces will increase? Can you realize as the speed of the child will increase, the resistive forces will increase? There will come a point where the resistive forces will be equal to the forward forces. There will come a point where the resistive forces will be equal to the forward forces. At this point, the resultant force will be zero, your acceleration will be zero, and you will reach a constant velocity as shown in the graph. You will reach a constant velocity as shown in the graph. Okay. So you can write everything here. You can write everything here. First of all, you will say, as the speed increases, as the speed increases, as the speed increases, this causes the resistive forces to increase. Perfect. Hence, as the resistive forces increases, beta, as the resistive forces increases, hence as the resistive forces increase, what will happen? The overall resultant force, yeah, the total resultant force, the total, yeah, you can say hence as the resultant force increases, it cancels out, or it cancels out the effect of forward force of weight. It cancels out the forward force of weight. Hence, as the resistive force increases, it cancels out the effect of the forward force of weight. The resultant force decreases. The resultant force decreases, and this causes the acceleration to decrease. And this causes the acceleration to decrease. Simple as that. This causes the acceleration to decrease. Simple. और एक्सेलरेशन टू डिक्रीज हो रहा है इसलिए यू आर बेसिकली हैविंग अ डिक्रीजिंग कर्व. लास्ट पॉइंट क्या लिखोगे बेटा? व्हाट विल बी योर लास्ट पॉइंट? व्हाट विल बी योर लास्ट पॉइंट? व्हाट विल बी योर लास्ट पॉइंट? यू विल से व्हेन resistive forces, or you can say air resistance, when air resistance equals weight, or the forward force, or the forward force, a constant terminal velocity is reached. A constant velocity or terminal velocity is reached. Simple as that. Nothing complicated. Simple. Okay, now I have a very, very, very कह लोगे bad question. Sir, why is the acceleration decreasing when downward? The speed increases, but why is it increasing with the decreasing rate and not at an increasing rate? बेटा यही तो ये मैंने लिखवाया है अभी. Why is the speed increasing at a decreasing rate? Because आपके पास resistive forces है ना बेटा. You have resistive forces that causes some amount of backward force. Backward force आएगी तो resultant force कम होगी. Resultant force कम होगी तो acceleration कम होगी. यही तो मैंने लिखवाया है अभी. हाँ, एफ इज इक्वल टू एम ए, समझ आई बेटा जिसने सवाल पूछा था। यस, लिटरली वही सवाल पूछ ही रहे हो जिसका आंसर अभी हमने 5 मिनट बैठ के किया। हाँ, अब इस पॉइंट पे आते हैं, लेट्स डू दिस। At time t is equals to 26 seconds, the front of the sledge is 35 meters from the wall. Perfect. At time t is equals to, let's minimize all this wording so that we have enough space to do the next word. थोड़ा सा इसको minimize करके we can shift it up. Perfect. Now let's read this out. At time t is equals to 26 seconds, the front of the sledge is 35 meters from the wall. Perfect. At time t is equals to 26 seconds. Beta time t is equals to 26 seconds. Well, let me draw it here. At time t is equals to 26 seconds. Let's erase all of this. This is not needed now. At time t is equals to 26 seconds. You are 35 meters away from the wall. Perfect. यही लिखा हुआ है. At time t is equals to 26 seconds. You are 35 meters away from the wall. Determine the distance between the front of the sledge and the wall when the sledge stops. Beta, you have to determine the distance between the sledge and the wall when the sledge stops. Beta, ये sledge कभी ना कभी stop होगी ना. What will be the distance between the sledge and the wall when it stops? You have to calculate this x. How are you going to do that? Very, very easy. Let's do one thing. Let's calculate the distance traveled by the sledge after 26 seconds. Let's calculate the distance traveled by the sledge after 26 seconds. So distance traveled by the sledge can be calculated as what? It can be calculated as area under the graph. Distance traveled by the sledge can be calculated as what? Area under the graph. तो बेटा ये एरिया अंडर द ग्राफ किस तरह कैलकुलेट करोगे? दिस इज अ ट्रायंगल. व्हाट विल यू से? 1 upon 2 into the base, that is, this is 30. From 26 to 30, that is 4. And the height is this value. This is 14. This is 14.4. This will be 15.2. Okay. So how have I come to a conclusion बेटा कि ये 15.2 होगा? ये भी देख लो. चलो बेसिक बेसिक चीज़ें भी कर लेते हैं. If you are going from 12 to 16, you are covering 4 units in how many boxes? 10 boxes. Perfect. That means one box will cover how many units? 0.4. This will be 15.2. Perfect. So the height is 15.2 multiplied by 15.2. What does your distance comes out to be? 1, 2. This comes out to be 30.4 meters. So basically, after 26 seconds, बेटा sledge कितना distance travel कर रही है? After 26 seconds, the sledge is traveling a distance of what? The sledge is traveling a distance of 30.4 meters. What will be this remaining distance x? What will be this remaining distance x? Very, very easy to calculate. 35 minus 30.4. This comes out to be 4.6 meters. Simple as that. Nothing complicated here. नहीं 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 बेटा, the sledge stops when you are applying a brake. Can you see here the child starts to apply a brake? The child and the sledge stops before they hit the wall. ये सिंपल लिखा हुआ है यहाँ पे. ये क्या सवाल पूछ रहे हो आज? तो आज तुमने जो है ना वो शायद नींद वींद सही नहीं की, इस तरह के सवाल तभी पूछ रहे हो. यस, योर आंसर कम्स आउट टू बी 4.6 मीटर. मुझे बताओ किसी को कोई कॉन्सेप्चुअल अंडरस्टैंडिंग में मसला है? यस, स्लेज बेटा वॉल को हिट नहीं करेगी. दिस इज रिटन इन द क्वेश्चन एज वेल. यस, ऑल क्लियर. Now let's move ahead. At time t is equals to 26 seconds, the child and the sledge begin to decelerate. ठीक है. Determine the size of deceleration. You have to determine the size of deceleration. Perfect. How will you calculate the size of deceleration? Do you remember that the gradient of velocity time graph is equals to your deceleration? How can you calculate the gradient? How can you calculate the gradient? Very, very, very easy. You will take 2 points. You will take 2 points. The first point will be this. The first point will be this. That is x-axis 26, y-axis 15.2. The second point will be what? X-axis 30, y-axis 0. Can you calculate the gradient here? Yes. y2 minus y1, 0 minus 15.2. 0 minus 15.2 divided by x2 minus x1, 30 minus 26. This comes out to be what? Negative 15.2 divided by 4. The deceleration comes out to be what? Negative 15.2 divided by 4. This comes out to be negative 3.8. Negative 3.8 ms minus 2 is your answer. Simple as that. Sir, can you zoom out? Yes, I can zoom out. You know. So your answer comes out to be negative 3.8 ms minus 2. Let's write it here. Negative 3.8 ms minus 2. Simple. Nothing complicated here. Let's further move ahead. Let's further move ahead. Now, the mass of the child and the sledge. The mass of the child is 46 kg and the mass of the sledge is 9 kg. Calculate the resultant force on the child and the sledge as they decelerate. बेटा आपने resultant force निकालनी है. How will you do that? Resultant force is equals to mass into acceleration. What is the mass? 46 plus 9. What is the acceleration? Negative 3.8. Can you multiply it and calculate the answer? Yes. 46 plus 9 multiplied by 3.8. This gives you an answer of 209. 209 Newton is your resultant force. You can ignore the sign when you are giving the resultant force का answer. You can ignore the sign when you are giving resultant force का answer. चल. Let's further move ahead. State the energy transfer that is taking place as the child is decelerating. Why the word size used and how does it tell that it wants as the अच्छा एक सेकंड मुझे एक क्वेश्चन आंसर करने दो why the word size used and how does it tell us it wants to give the gradient Peter can you realize here I think you are asking about this can you realize here that you have to give what that you have to give the deceleration perfect you have to give the deceleration whenever always remember gradient of velocity time graph is what gradient of velocity time graph is equal. Yes. Good. Shabash. Good. Yes, one thing that you need to understand here is ये size का मतलब क्या है? This size basically means only the magnitude. Very good. This size only means only the magnitude. Perfect. So your deceleration will not contain a negative sign. It will be a positive sign. एंड आई हैव टोल्ड यू एज वेल बेटा मैंने ये बात बताई भी थी कि जब भी डिसैलरेशन या रिटार्डेशन का वर्ड लिखा होगा व्हेन एवर डिसैलरेशन और रिटार्डेशन का वर्ड इज रिटन you will always write the values without signs perfect and whenever acceleration ka word is written you will write your answer with signs perfect chal now here your deceleration was coming out to be 3.8 ms minus 2 and how do I know that I have to calculate gradient? Because always remember that the gradient of velocity time graph is equals to deceleration or acceleration, whatever you want to call it. The gradient of velocity time graph is equals to deceleration or acceleration, whatever you want to call it. Here as well, you will put a positive here. The answer for force will come out to be 209 Newton. Sawal clear hai bhai? Yes or no? Is this question clear? Achha, now, state the energy transfer that is taking place as the child and the sledge decelerate. Beta, as the child and the sledge decelerate, one energy is getting lost. That is, kinetic energy is getting lost or kinetic energy is decreasing. This is pretty obvious. Why? Because the velocity is decreasing. There is one more energy that is getting lost. There is one more energy that is getting lost. Can you realize that the height of the sledge and the child is decreasing? Can you realize that the height of the sledge and the child is decreasing? That means gravitation potential energy will also decrease. Simple. So both of these energies will decrease. Kinetic energy will also decrease. Gravitation potential energy will also decrease. Kinetic energy will also decrease and gravitation potential energy will also decrease. They will get converted into what? Both of these energies will get converted into what? Thermal energy. So let's write it in a clean manner. Let's write it in a clean manner because this will not be accepted in the examination. You can say kinetic energy and kinetic energy and gravitational potential energy and gravitational potential energy gets converted into thermal energy. Gets converted into thermal energy. Simple as that. Nothing complicated here. Shabash. Now let's further move ahead. At time t is equals to 26 seconds, when the brake is first applied, the child jerks forward on the sledge. Perfect. At time t is equals to 26 seconds, when the brake is first applied, the child jerks forward. Explain why. This is because of the mass of the child. The mass of the child offers inertia, or you can say the mass of the child resists the change in the motion. So you can say the jerk effect is due to what? Very good, very good, very good, Misa. You can say the mass of the child resists the mass of the child resist change in the state of motion. Change in the state of motion. Simple as that. The mass of the child resists change in the state of motion. Simple, nothing complicated. Let's further move ahead. Let's see this. A parallel beam of light traveling in air is incident on a glass lens. Perfect. The beam is perpendicular to the lens as shown in figure 8.1. Perfect. The dashed line indicates the position of the lens. Beta ye position of the lens hai. The center of the lens is dot C. Perfect. This is the center of the lens. The lens is the diverging lens. On figure 8.1, indicate the shape of the lens by drawing the outline of the lens around line P. अच्छा डाइवर्जिंग लेंस किस तरह बनता है बेटा डाइवर्जिंग लेंस के लिए फर्स्ट ऑफ ऑल ड्रॉ टू लाइंस लाइक दिस and then somewhat like this. I have made very small lines. Let's increase the width of them so that we can give a proper curvature here. 1 second. Yeah, somewhat like this. This is your diverging lens. Perfect. Now, draw the part taken by the ray of light after it passes through the lens. Draw the part taken by the ray of light after it passes through the lens. Perfect. So, how will we draw the path of a rays of light as it passes through the lens? They will diverge like this. They will diverge like this. Also, the ray passing through the center will pass undeviated. Always remember, any ray passing through the center of either a diverging lens or a converging lens, it will pass undeviated. Perfect. Let's move ahead. Diverging lenses are used to correct short-sightedness. Okay, what is short-sightedness? When you cannot properly see distant objects. Now I am not sure what the question is asking. Let's see. and you cannot properly see distant objects. That is known as short sightedness. On figure 8.2, a figure 8.2 is a simplified diagram of a short sighted eye. Light from a distant object strikes the eye's lenses and enters the eye. Perfect. On figure 8.2, continue the three rays in the eyes until they reach the back of the eye. Now, do you remember that in short sightedness, your लेंस क्या करता था आपका लेंस शॉर्ट साइटेडनेस में in short sightedness your light rays would converge what before the retina in short sightedness your light rays would converge before the retina. Let's make them. In short sightedness the light rays converge before the retina, somewhat like this. Let's draw it properly. Somewhat like this. And let's also shape this correctly. Mhm. Maybe like this. Yeah. In short sightedness, your light rays used to converge before the retina. This used to be your image. Obviously, you can extend these lines as well, like this. Obviously, these drawings are much easier to draw on paper than on a digital format. To state how the image of the distant object detected by a normal eye differs from the image detected by the short sighted eye. Beta, how will both the images differ? Yes, image in a normal eye will be what? Image in a normal eye will be sharp and focused. However, image formed in a short sighted eye will be blurry. You can write it here. Image formed, image formed in a normal eye will be sharp and focused. Whereas image formed in a short sighted eye will be blurry. In a short sighted eye will be blurry. Perfect. Let's further move ahead. Let's move ahead. Now, let's see part 2. Explain how a diverging lens corrects the sight of a short sighted eye viewing a distant object. Now we have to tell how does a diverging lens remedy short sightedness. Beta, how do diverging lens remedy a short sighted eye? क्या करेगा डाइवर्जिंग लेंस? डाइवर्जिंग लेंस will cause the light rays to diverge before entering the eye. डाइवर्जिंग लेंस क्या करेगा? डाइवर्जिंग लेंस will diverge the light rays, will diverge the light rays before entering the eye. Diverge the light rays before entering the eye. Simple. Let's further move ahead. The focal length. Now, this is a beautiful question. Please pay attention. यहाँ पे ray diagrams बनेंगी. This will be interesting. And this is a ray diagram for a diverging lens. So this is a hard question. Just pay attention. The focal length of a diverging lens is 4 centimeter. Perfect. An object of height 3.5 centimeter is placed 6 centimeters from the center of the lens. Perfect. An object that is of 3.5 centimeters is placed 6 centimeters from the center of the lens. On figure 3, 8.3 is a full scale diagram. Perfect. Drawn on a grid on which the dashed line L represents the lens and the arrow O is the object. Perfect. By drawing on figure 8.3, find the possible positions of the image of object O. Draw image I and label it I. Perfect. You have to draw the image I and label it I. First and foremost, what do? We draw the focal length. We draw the focal length. This is your focal length on the left hand side. This is your focal length on the right hand side. Since focal length is 4 centimeter, perfect. Now you have to draw the image. First and foremost, what do? First and foremost, we draw a line that comes from the top and passes through the center of the lens like this. First of all, we draw a line that comes from the top of the object and passes through the center of the lens. Let's make it more appropriate. Let's erase this, yeah. And let's shift this thoda sa upward. 1 second. We have to be precise, very, very precise. ये शिफ्ट हो गया है. I think no, नीचे से भी शिफ्ट हो गया ना. That's bad. One second. Oh, I think I know what trouble this is. Sure. Let's draw it again. So let's draw it from the tip of the object through the central point like this. And let's extend it backwards. यहाँ पे you go to the top. बेटा देखो, हर चीज इसमें प्रिसाइज करनी होगी. बिल्कुल प्रिसाइज ड्राइंग बनाना है इसमें. Yeah, this is your ray passing through the center. This is the first ray. Now here again I have made a mistake. I have taken a very thicker line. Make sure you take thin lines. ठीक है, thin lines thin pencil से बनाना. Don't utilize thick lines because they can mess up your drawing. Now what will be your second line? Your second line will be a ray passing parallel to the principal axis like this. Your second line will be coming from the top of the object parallel to the principal axis like this. And if I extend this ray backward, it will pass through the focal point. Why? Because this is a diverging ray or diverging lens. 1 second. We can also shift this thoda sa niche. Yep, I guess picture perfect. Now, what else I have told you? First of all, since this is a diverging lens, rays parallel to the principal axis will pass through the focal point if you extend it backward. This is happening here. And this backward ray will be dotted. Why? Because this is an imaginary line. Where is your image formed? This is your formation of image. You will label this as I as suggested by the examiner. Find the position of the image of I, draw image I and label it I. Perfect. Explain whether the image is real or virtual. Whenever you have diverging lens, what will you say, beta? Virtual image is produced. Virtual image is produced. Perfect. You can say virtual image is produced. Virtual image is produced. Perfect. Let's further move ahead. Any questions here? 1 second. Let me see. थर्ड रे कौन सी? अच्छा, ये जो बैकवर्ड एक्सटेंड कर रहा हूँ, ये द रे दैट आई एम एक्सटेंडिंग बैकवर्ड, इसका पूछ रहे हो? दिस रे? बेटा always remember in a diverging lens, if your ray is parallel to the principal axis and it hits the lens, then if you extend the ray backward, it will pass through the focal point. Simple. Please remember that this is a diverging lens. Don't apply converging lens ke rules here. This is a diverging lens. Let's further move ahead. On the grid in figure 8.3, write an E in a position from which an eye can see the image. बेटा हमारी आई कहाँ से ये इमेज सी कर सकती है? वेरी वेरी इजी। योर आई कैन सी द इमेज फ्रॉम हियर। योर आई कैन सी द इमेज फ्रॉम हियर। ई सिंपल। योर आई कैन सी द योर आई कैन सी द इमेज फ्रॉम हियर। यस यस आई विल शो द क्वेश्चन, डोंट वरी अबाउट इट, बस मुझे कंप्लीट करने दो पहले। Determine the linear magnification. You have to determine the linear magnification. How will you do that? How are you going to determine the linear magnification? Very, very easy. Height of height of image divided by what? Height of object. Perfect. Beta, what is the height of image? What is the height of image? How will you calculate that? Just zoom in a bit. Just zoom in a bit. Okay, so we had this dot quite thick. इसको थोड़ा सा हम ना हम thick कर देंगे. Oh, 1 second. How will we do that? I hope we have a. Let's make this a little bit thin ताकि हमें exact position पता चल जाए. I think the exact position is this. I think the exact position is this. ये क्या होगा बेटा? What will this be? What will this distance be? What will this distance be? Very, very easy to calculate. Why? Because you know कि 1 सेंटीमीटर कितने बॉक्सेस कवर कर रहा है? 1 2 3 4 5. So 1 सेंटीमीटर की हाइट is being covered in 5 boxes. How many boxes are these? How many boxes are these? If you analyze, how many boxes are these? चलो, let's count it out. These are 1 2 3 4 5 6 7. So if 5 boxes is covering a height of 1 centimeter, 7 boxes will cover a height of what? 7 boxes will cover a height of 1.4 centimeter. The height of the image is 1.4. Chalo, let's further move ahead, bhai. Now, now we have started the recording. So beta height of image आ रही थी 1.4. The height of image was coming out to be what? 1.4. What was your height of the object? The height of the object was 3.5. Divide कर दो, you will get your linear magnification. Linear magnification किसके equal आती है बच्चों? 1.4 divided by 3.5. This comes out to be 0.4 as your linear magnification. अच्छा. The power supply in an electric circuit is a battery of electromotive force 12 volts. Perfect. State two ways in which the EMF of a battery differs from an alternating power supply. We have to state how an EMF differs from an alternating power supply. Yes. How does an EMF differs from an alternating power supply? बेटा alternating power supply positive negative हो सकती है. Alternating power supply changes direction. However, EMF does not change direction. ये लिख लो यहाँ पे. You can say alternating current keeps changing direction, keeps changing direction. However, EMF has a single direction or a constant direction. Simple. Constant direction would be better in my opinion. Okay, what could be the second difference? What could be the second difference? EMF has a constant value. EMF has a constant value. However, वैसे आप सेकंड पॉइंट ना भी लिखो ना. लेट से यू अगर ऑल्टरनेटिंग करंट के बारे में ना भी लिखो, लेट से यू डोंट राइट ऑल्टरनेटिंग करंट हैव अ वेरिएबल वैल्यू, अगर ये ना भी लिखो तो भी आपको पॉइंट मिल जाएगा. बट आई यूजुअली राइट इट सो दैट द एग्जामिनर डजंट हैव एनी वेज टू कट माय मार्क. ईएमएफ हैज अ कांस्टेंट वैल्यू. However, alternating current has a value that keeps changing, has a value that keeps changing. Perfect. Let's further move ahead. The circuit includes three resistors and two open switches S1 and S2. Perfect. So there are three resistors and two open switches. Perfect. Now, हाँ हाँ ये दिस इज पॉसिबल. अगर स्पेस गिवन में पूरा सेंटेंस कंप्लीट नहीं हो पाता तो तू यू राइट इट इन अ कंसाइज मैनर, ट्राई टू ओमिट एक्स्ट्रा थिंग्स. जो एक्स्ट्रा थिंग्स मैंने यहाँ पे लिखी हैं यू कैन ओमिट दैट. ठीक है. जिनकी राइटिंग छोटी है वो सारी चीज़ें लिख सकते हैं. YZ is a straight horizontal section of connecting wire that lies between two magnets. अच्छा YZ क्या है? YZ is a straight horizontal section of connecting wire that lies between two magnets. Perfect. S1 is now closed. Perfect. S1 is now closed. S1 is now closed. Calculate the current in YZ. You have to calculate the current in YZ. Perfect. If you analyze, if S1 is closed, what will be the circuit? If S1 is closed, your circuit will start from here, go like this, and like this. Can you realize if S1 is closed, 20 ohm and 28 ohm are in series? What will be the total resistance? Total resistance is 48 ohm. The voltage is 12 volts. Perfect. Current की value क्या आ जाएगी? V is equals to IR. Voltage is 12. Resistance 48 divide कर दो. Resistance 48. Current comes out to be what? 0.25 ampere is your current in visor. Now you also have to explain why this wire YZ experiences a force. We have to tell why wire YZ experiences a force. The wire YZ is carrying a current in a magnetic field. The wire YZ is carrying a current in a magnetic field, hence it experiences a force. इसको लिख लो. The wire YZ carries a current in the magnetic field, hence it experiences a force. Simple. Let's further move ahead. अच्छा जी. Take the box below which describes the direction of force on wire YZ. बेटा हमने direction of force निकालनी है. Do you remember whenever we have to calculate direction of force, which law do we apply? Whenever we have to calculate direction of force, which law do we apply? Fleming's left hand rule. Let's apply Fleming's left hand rule. Let's apply Fleming's left hand rule. The magnetic field is from north to south. So your first finger points like this. Where will your direction of current be? Current flows from positive to negative. So your current ki direction will be inward. Your direction of current is inward. Where does your force points? बेटा आपकी फोर्स कहाँ पॉइंट करेगी? वेयर विल योर फोर्स पॉइंट? फोर्स आपकी डाउनवर्ड आ रही है. ओ सॉरी, फोर्स डाउनवर्ड आ रही है बेटा. ये अपवर्ड कौन कह रहा है? फोर्स डाउनवर्ड आ रही है. क्या कर रहे हो? फोर्स डाउनवर्ड आ रही है. आई शुड हैव केप्ट द फिंगर्स माई सेल्फ. एक सेकंड में ग्रुप में पिक्चर भी भेजता हूँ भाई. ये आपकी फर्स्ट फिंगर है मैग्नेटिक फील्ड की. करंट इनवर्ड है, फोर्स डाउनवर्ड है. बेटा फोर्स डाउनवर्ड आएगी, अपवर्ड कौन कह रहा है? 1 सेकंड. डाउनवर्ड फोर्स आएगी. मैं ग्रुप में इसकी पिक्चर भी भेज देता हूँ. अच्छा ये बड़ा कंफ्यूज करता हूँ मैं. मुझे चैट देखनी ही नहीं चाहिए. चल. नाउ हाउ टू अप्लाई फ्लेमिंग्स लेफ्ट हैंड रूल या फ्लेमिंग्स राइट हैंड रूल? बेटा whenever you have to calculate the direction of force, ये हमारी डिस्कशन हो चुकी है. Whenever you have to calculate the direction of force, जब भी आपने डायरेक्शन ऑफ फोर्स निकालनी है, whenever you have to calculate the direction of force, which law will you apply? Fleming's left hand rule. Fleming's left hand rule. Whenever you have to calculate direction of what? Current. Which law will you apply? Fleming's right hand rule. Fleming's right hand rule. परफेक्ट हो गया बेटा. चलो आगे बढ़ते हैं. Explain how the direction of the force on YZ was determined. बेटा how the direction of force on YZ was determined. क्या लिखोगे यहाँ पे? वही लिखोगे जो किया है. वही लिखोगे जो किया है. कुछ रॉकेट साइंस नहीं लिखनी. You will say Fleming's left hand rule is applied. Left hand rule is applied. Magnetic field. Magnetic field is towards the left. Towards the right कह लो. From left to right कह लो या towards the right कह लो. And current is flowing from Z to Y. Simple. Switch S2 in the circuit in 9.1 is now closed. अच्छा, आपने switch S2 को भी close कर दिया बेटा. You have closed this switch as well, S2. You have closed up this switch S2 as well. Perfect. Now, calculate the total resistance of the circuit. बेटा, if you close the switch S2, total resistance of the circuit किस तरह निकलेगा बच्चों बोर्ड पे? If you close the switch S2, let me erase all this highlighting. This 30 ohm ka resistor and 20 ohm ka resistor will become what? Parallel. How do you calculate the resistance in parallel? 1 upon 30 plus 1 over 20 is equals to 1 over RT. Can you calculate the total resistance? Yes, 1 over 30 plus 1 over 20, 1 divided by answer. The answer comes out to be 12 ohms. Perfect. The parallel resistor ka combination has a resistance of 12. This is 28. Add 12 plus 28 to get the total resistance. So you can write here 1 over 30 plus 1 over 40 is equals to 1 over R total. R total for the parallel combination comes out to be 12 ohms. 12 plus 28 is your total resistance, that is 40 ohm. Explain what happens to the force on YZ as the switch S2 is closed. Beta, as the switch S2 is closed, what happens? As the switch S2 is closed, what happens? The resistance, what? Resistance increases. Okay, as the switch S2 is closed, what happens? Your resistance increases. Your current decreases. As your resistance increases, 1 second. Total resistance पहले क्या थी? अच्छा ठीक है. Resistance is decreasing. Perfect. So as you close the switch, the resistance decreases. As the resistance decreases, current will increase. The force on YZ will increase. You will say as resistance decreases, the current increases. Hence, the force on YZ increases as well. Hence, the force on YZ increases as well. Simple as that. Okay. Let's move on to the last part. The current in the 20 ohm resistor is I20. The current in the 30 ohm resistor is I30. Calculate the ratio of I20 over I30. बहुत easy है. इससे easy सवाल हो नहीं सकता, सिर्फ difficult लग रहा है. You have to calculate the ratio of I20 and I30. चलो. हमने क्या निकालना है बेटा? यू हैव टू कैलकुलेट द रेशियो ऑफ I-20 ओवर I-30 पे। यू हैव टू कैलकुलेट द रेशियो ऑफ I-20 ओवर I-30। नाउ रिमेंबर, करंट का जो रेशियो होता है दैट इज इनवर्स। करंट का रेशियो बेटा इज इनवर्स टू द रेशियो ऑफ रेजिस्टेंसेस, इनवर्स ऑफ रेशियो ऑफ रेजिस्टेंसेस। सिंपल। What is the ratio of resistances? R20 over R30 का ratio of resistance क्या होगा? 2/3। Similarly, if I inverse it, what will happen to the current ka ratio? 3/2. Simple. This is a key point that you must remember. Everything else is a piece of cake. This marks the end of this paper. If you have any questions, you can ask me right now. बेटा कोई सवाल है तो पूछ सकते हो। यस।